Hello everyone. In this video we will explain the basic connections for the C11G Breakout board. We have included in the description below a table of content with timeline so you can skip to the connection you need. We will be explaining proper connections for power and E-stop, basic driver and motor connection, basic inputs like mechanical and proximity switches and probe, output connection, spindle speed control connection, and VFD spindle connection. Before we start explaining each connection, it is important to remind you of proper electrical safety, connecting breakers or fuses to protect from electrical hazard. To connect the E-stop, we use the pin 10 input and the enable, which powers the outputs. The pin 10 sends signal to Mach 3 or any other software you're using, and we should configure output pin 17 to enable the C11G board, setting the safety charge pump to enable with the little jumper. We should connect the E-stop to the 5 volts terminal and the other end to the enable in pin 10. This way, we power the outputs and send signal to Mach 3, and the green ready LED should go solid. And finally, you will connect the 5 volts power supply to 5 volts and ground terminals. We will be connecting the driver using pin 2, pin 3, and common. Now for common in this case, we will be setting the jumpers for ground. Pull or step will be connected to pin 2. Common, which is ground in this case, should be connected to pull negative, direction negative, and enable negative. And pin 3 should be connected to direction. So this will be connection for X-axis, and same should be for Y, Z, and A axis. Now we should connect power to voltage and ground terminals. And finally, we connect motor to A+, A-, and B+, B- as per technical specs of your motor. For inputs, we have pin 10, 11, 12, 13, and 15. Now, if the inputs are 5 volts, jumpers should be set to pull down. If inputs are ground, then jumpers should be set to pull up. We have input terminals, 5 volts terminals, and ground terminals. In this case, jumpers will be set to pull down we have a mechanical limit switch connected from 5 volts to input 11. Now we have a PNP proximity switch connected to 5 volts, input 12, and also ground to close the connection and power the LED. Normally we will connect pin 11, 12, and 13 for X, Y, and Z limits, and pin 15 for probe, touch plate, to set C0 or any other probe function. For output signals, we use terminals for pins 1, 14, 16, and 17. We also have Relay 3, Relay 2, and Relay 1. Which uses the same pin as 14, 16, and 17 or pin 1. We can select to use pin 17 or pin 1 with jumper in the back of the relay. Now keep in mind the pin 17 is the same pin used in the terminal but also used for the safety charge pump. Same case for Relay 3 and pin 1 terminal, so we can use relays or terminals. We have connected a solid state relay to pin 16, same as Relay 2, using ground to relay negative connection and pin 16 to positive input of relay. Terminals for relay are normally open, voltage in, and normally closed. Here we connect a 110 AC solenoid. So basically we connect the neutral and ground directly to solenoid and live to voltage in of relay, and solenoid power to normally open. To connect the spindle speed control, we will be using 12 volts, voltage in terminal, 0 to 10 terminal, and ground terminal. We have a potentiometer to adjust the 0 to 10 voltage. Now we connect ground, 0 to 10 volts, and in this case 5 volts, which we will need to adjust the potentiometer, setting it to max and then tune it down. We connect the spindle to the spindle terminals. And finally, 110 volts required for this specific spindle speed control. Now, it is very possible that the voltage provided by the speed control is very low, so we will not get full spindle speed. In this case, we could use an external power supply, connecting it to voltage in and ground. We will only disconnect the voltage coming from the spindle control and leave ground connected to make it common. And finally, we'll be connecting a VFD with a 3 kilowatt spindle. we'll be connecting 12 volts and 0 to 10 terminal. Adjust potentiometer if needed, and ground. We should use relay 1, which is pin 14, and relay 2, pin 16. We will also need to set the jumpers to desired mode. We have international and US mode. For US mode, relay 1 runs clockwise and relay 2 runs counterclockwise. On international mode, relay 1 turns spindle on clockwise and relay 2 will determine the direction. It will basically run counterclockwise when both relays are on. We will be setting jumpers to international mode, since we will only be running spindle clockwise, and we will be able to use relay 2 for any other connection like vacuum or cooling connection. We will connect normally open of relay 1 to forward, ground to ACM, voltage in into 0-10 volts, and DCM to voltage in of relay. We must connect a 12 volts power supply to 12 volts terminal of C11G board and ground, making it common with a VFD ACM terminal. We have 4 wires to connect the spindle. The first 3 could be in any order. If the spindle is running counterclockwise, we will change the order of the connection until spindle runs clockwise. The 4th wire is ground, and we can determine this by checking continuity between the spindle and one of the 4 wires. To power the VFD, we will connect live, neutral, 4 220 AC 2-phase, and live, neutral, 410 AC single phase. To connect the C11G to the PC, you could basically use a DB25 cable and connect to the computer parallel port. We will be using the UC100 that connects to the PC through the USB connection. And also we'll be using an ESS, Ethernet Smooth Stepper, which is faster and connects to the Ethernet port. Which is more reliable and has 2 additional ports. So we connect the C11G to port 1 with a IDC to DB25 ribbon cable and the PC through Ethernet cable. And we still have 2 additional ports to connect another C11G or C10 for additional functions. We will now connect all the components and run Mach 3 using both the UC100 and the ESS. Let's first use the UC100. Let's check mechanical limit switch. Proximity limit switch. Probe touch plate. And E-stop. Let's reset Mach 3. Safety charge pump enable and ready to go. Now let's set tool height with probe. We first confirm touch plate height. Coolant. And vacuum where we connected the air control solenoid. And finally, the spindle speed control. Now let's run a test G-code. Everything working fine. Now let's run the same test using the ESS and the VFD. Probe OK. Proximity switch OK. Mechanical switch OK. Setting tool height with probe OK. Coolant OK. Vacuum OK. Spindle OK. Now again, let's run a G-code test. Everything running smooth. Thanks for watching. Don't forget to check our videos and tutorials in our website and YouTube channel.